Thank you for your kind introduction of me, and also thank you for organizing this seminar very well, and also moderating these things. And thank you for audience as well. And today I am going to present a blockchain prototype system I developed for scaffolding work process at the construction site. Actually, the research work is a part of ongoing my lab project, which is the social safety platform development. Today, I just on not just only about the how and why blockchain system in construction application area. Also, I want to share that the lessons learned I got during this blockchain small prototype development and in this specific construction work supply chain. And the context might be today, and at first I'm going to go over about the safety issues of scaffolding work, will be overviewed, and field issues in current scaffolding procurement, and the issues and key value data in blockchaining will be discussed, and the system development environment and structure of the system and how it works demonstrated. And we'll conclude with the findings and lessons learned during this research work. As you know, the scaffolding work is the temporary facility, but it plays very crucial role for entire building operation. Whenever you have a chance to watch the construction site, you may see, you may notice workers moving around there, and based on the OSHA's statistics, over 65% of workers are doing their job on the scaffolding. But like you can see in the photos in here, and the management practice of this temporary facility has been so poor, such as no guardrails and missing pipe and no plank, etc. According to OSHA data in 2013, this kind of poor practice caused 60 deaths and 4,500 injuries, and it cost the 90 million loss. And similar to United States, in Korea, during the last 5 years, the fatality related to scaffolding is accounted to 25% of the total fatality. Most of them are falling accident that scaffolding caused the 417 falling deaths, which is 85%. And 63% of those fatality are happened at small size construction site. Most surprisingly, in this year, 2021, construction inspection of Korean Occupational Health and Safety Organization agency shows that missing installation of guardrail and plank has the highest percentage in an inspection result. In the current, the management and inspection practice of the scaffolding procurement is a document-based manual process, and the individual stakeholders generate some information. Those information is not connected to each other and is not properly open. It is falsifiable, just for preparing for submission to owner and inspector. However, with this document-based manual inspection, it is so hard to confirm that required quantity is properly ordered and verified, and the proper installation at right site location as well. So in order to verify and assess proper procurement and installation, the key data, such as the quantity information on required and ordered and supplied quantity, and drawings and installation photos with time point and location, must be compared to previous stage. In practice, the contractor usually estimates the total quantity required based on drawing, and then order necessary quantity according to work schedule. In this ordering process, the required total quantity should be compared with some of this scheduled order quantity. And that supply stage in the suppliers, the invoiced information supplier creates, such as location, name of contract, and quantity, delivery date, and drawings, must be compared with this ordering information as well. And an installation stage, all this invoice information should be compared with all the ordering information as well. So at last, the installation date and key portal data should be compared to invoice data as well. In order to overcome these key issues of current scaffolding procurement and inspection process, it is necessary to secure reliability of key data I mentioned before, generated by stakeholders, and also to be automated data comparison and the verification process, and at each stage need to be. So as you know, the blockchain is as a distributed and decentralized ledger technology. And with this decentralized DF technology, all individual, general contractor, supplier, and inspector, and stakeholder information can be stored immutably in this ledger. And then consensus-based smart contract function can be executed automatically to secure the reliability of data and to automate the verification process. And however, in adopting blockchain DF technology for this scaffolding process, may be same as for all other construction blockchain application as well. The scalability, and scalability means the need to confirmation of all nodes, and increase the user, and the transaction speed will be slowed down. We have to consider these things and how to prevent the transaction speed slow down. And number two is the confidentiality in construction industry, the supply chain practice. And the many companies are reluctant to open their information to the public because it could be their business know-how as well, right? So we need to consider how to allow this information to needed people, and in other words, just only channel project participant allowed to access those information. And also, as you know, that all the construction information is based on drawings. Drawing the file size is too big, and also some photos is embedded, and those photo information also is big size. It is not able to store all this information into the small block. So we need to consider how to surface the block size if the information goes getting bigger. So we need to consider these things. And also in this the blockchain procurement and inspection process, we should know that all the information created by stakeholder in this procurement process must be verified by trusted third parties such as government agency and then the inspectors who has authority as well. And then considering those issues, we compared which of blockchain is better for this scaffolding DF development in aspect of access level, information access level, and then some consensus process and network and performance and platform. So as you know that the public blockchain can access anyone, and then in the consensus process, there is no permission. So anybody who is in the network can get into consensus process. And also the network is totally decentralized. So it caused the very low speed. And as you know that the mining in Bitcoin, something like. But private blockchain is participant can be pre-selected, and also the consensus, the process can be permissioned for specific participants, and also some network can be partially decentralized. So the transaction speed can be higher than the public blockchain. So recently there are many types of private blockchain platforms and has been the open to public. So there are Hyperledger Fabric and R3 Coda and Kicem such as. So we chose that the private blockchain, and then we compared some of private blockchain platforms. And then we chose that the Hyperledger Fabric can depict, as I mentioned, scalability and then key features of scaffolding work. So Hyperledger has a high throughput and then low latency and post-transaction speed can need more scalability, as you see in this diagram and a graph. Hyperfabric also can establish a third-party government agency as a specific verification endorser and block creator, order, which is called creator. So based on this, considering the scaffolding work, the key features, procurement process, and also the characteristic of a different type of blockchain, and we chose like this the system environment. We chose that the system environment as the Ubuntu in a Linux-based operation system is used for setting the peers and Hyperledger Fabric. And also VirtualBox software is used for operating to create the Ubuntu-based virtual service. In this case, 11 peers created on 2 computers. And the Hyperledger Fabric is used for establishing blockchain network and data model. And also, the Go language is used to construct chain code that provide function to read and write compare data to the block. And also we developed the user interface, which is called the front end, the design. And the backend is a blockchain system we developed, but in the user just need that the user interface front end. So we use the JavaScript to use that to forward all the comment from front end user interface to the backend to invoke the chain code. And then the system is configured like that, considering that the confidentiality and scalability and the storage problem is in this scaffolding procurement application area. So as I mentioned, the company does not open their information to the public. So it is allowed it only peers in the same channel, and the channel means in the project, and the peers can share and access blocks. And the users authority can be defined as the membership service provider, and which is the function of the hyperledger public. And also to consider scalability, again, if user increases, then the transaction speed will be slowed down. So we need to control who can, create block and endorse. So only third party and who has the public agency and local government and authorized the inspector can create and has a permission to validate transaction proposal made by the stakeholders, and then they are allowed it to create blocks. And also we consider to minimize the data size in the block, and by using that some big original data goes into the off-chain database. But on-chain block, we just store that key value data in this distributed ledger. So actually, we did that we created the hash and extracted metadata for portal data stored in the block, and also the hash value of drawing stored in the block. We designed like that. And this shows that the consensus algorithm we developed for this. And we have, in this diagram, we have 5 groups. This general contractors group and supplier group, inspector groups, and endorser group, who has the authority to endorsing and creating the blocks. And order group is creating block, which is in this case is similar, the same. And also, to speed up the transaction process, we use that the hyperledger leader peer the functions as well. This leader peer can share the block information and in his group. For example, in here, as you see, if user 1 in contractor group as input order information, then transaction proposal is worked in this DApp and in the blockchain network. Then the peer endorse group and verifies the proposal and issue endorsement based on their endorsement policy. We can set it up. Right? In this case, an endorser group should agree all these things all together and on that the specific proposal. And the order group create a block and with endorsement, and then share that block information is shared to the leader peer in each group. In this case, the red color people is the leader group, leader peers. And then this leader peer got the block information, share that information in his group. The users who inputted some information can access to the DApp, and then they can confirm their inputted data as well in here. This shows about this flowchart demonstrate how to chain blocks and information flow in blockchain system. In establishing network and system 0 and to the N blocks can be created, right, called Genesis block. And I think earlier this morning in Professor Sang-Bong Kim introduced about how to create block, and has information on channel and membership service provider. All this configuration can be in this network. And 1 to the N block has chain code for in a smart contract, which are able to read and write, compare information. We can configure it here. and the contractor user input all the information, and it is stored these N+1 blocks. And among them, big size drawing files is stored in off-chain, and DB, only its hash value stored to the block. And then invoice information, same thing in the supplier, and create invoice information, and then is compared and verified with this N1 block is compared, right? And using smart the contract function and such whether the drawing is matching and the time point can be compared. Then all relevant data are stored in this number N+2 block in this N+2 block. Finally, delivered scaffolding are installed and is required key portals uploaded. Then the metadata of portal and such as GPS and user information and time point are extracted based on the portal information and hash valued, and then the portal taken time is compared to end block information. End block information is compared. And then user and GPS is compared with channel information, project information in here. Then all the verification information goes into number 3 box, right? So in this, the inputting and comparing and verification process has been done. All the government agencies, the inspector also, who has authority to access information each stage. So all the information can be seen, and also the comparison data can be seen in each stage, supply information and some installation information. And then also the verified the result data through smart contracting function. This is example. This is okay.
This is sponsor.
Okay.
Can I ask you to summarize in about a minute or so? I'm sorry.
Okay, I'll do that. I'll do that.
Okay, thank you.
This demonstrates about how we code it, and with JavaScript and the chain code for verification and comparison. This is the as I mentioned about front-end design we developed and in a user group then to demonstrate blockchain system operating. So you can see that all the general contractor just click that information, all the information goes over this. All right, this is the something about the developer can check about the block information using the HyperEdge Explorer. And in conclusion, and we did this approach. First, we did some scaffolding the procurement process, and we need that the data reliability. And we need it, and also we need to automate all the procurement and inspection process. So we developed the workflow and also key value data we extracted. So we chose that some HyperEdge fabric, what kind of blockchain technology based on this reliability, trust protocol, and efficiency. So system prototype and established distributed data and on-chain storage and partially decentralized and a smart contract function has been used. And we learned that this simple application, as I mentioned in the beginning of this presentation, the simple prototype development is a part of my lab, the blockchain-based construction safety social platform research. As shown in this slide, all the job site safety issues and that are required to check rule compliance, such as hazard detection, sensor detection, sensor data, and certificate, and installation field data could be blockchained and could be integrated with the emerging technology, AR, VR, IoT, and machine learning. And then all these things can be blockchained as the platform. I believe this blockchain integrated approach has a great potential and would bring the enormous benefit for the construction industry. Thank you, my presentation. So I think I took a little more time. This is the end of my presentation. Thank you for your attention.